All right, so this is section 5.1 in your textbook, and it talks about adding and subtracting polynomials. And we have this definition to start off with about what even is a polynomial, right? And it's just an algebraic expression where you have whole number exponents, right? So 5 and 2, and there's an understood 1 there, right? And we write polynomials with the exponents counting down. Okay, so what that means is descending order, right? So that means that your polynomial is in standard form whenever your um, exponents are descending, are counting down, right? So this one, 5, 2, 1, 0. Okay, that is descending, right? You don't have to have 5, 4, 3, 2, 1, 0. They just have to be descending, right? So if you had 5, 6, that wouldn't be descending, right? And then we have some definitions here. Probably most stuff that you are used to, or you've at least heard probably once before um, in math. Okay, so if we have a polynomial and it just has one term, that's a monomial. Okay, so just one term. A polynomial with two terms is a binomial, and then three terms is a trinomial. Okay, and then here's an example of each of those. And if a polynomial has more than three terms, it just doesn't have a special name. Okay, so we would just call that a polynomial, right? It was just a regular polynomial if it has more than three terms. Then we have what's called the degree of the term, and that's the sum of the exponents of the variable. Okay, the sum of the exponents of the variable. So that would be us adding n and m together. So whatever your exponents are in that term, just add them together, and that's the degree of the term. The degree of the polynomial, so this is the degree of the whole line, basically. It's the highest degree of all the terms. So if you find each degree of the term, right? So if we have a big, long polynomial, you'll find each degree, and whichever one is the highest is the degree of the polynomial. And then your leading term is the term with the highest degree. So whatever is your highest degree, whatever number is attached, that is your leading term. I mean, the whole thing is your leading term. The leading coefficient is the number that's attached. Okay, so we're going to go over an example of all of that right here. So we have this example 5.1.1, 2x squared minus 9x to the fourth minus x plus 5. Okay, if we want the degree of the polynomial, so we're going to look. We have 2, 4, 1, and 0. Okay, the degree of the polynomial is the highest exponent, so it's 4. The leading term, okay, so we just found that the degree of the polynomial is 4. So the leading term we can see with our definition up here is the term with the highest degree. Okay, well, the highest degree is 4. So this is the leading term. The leading coefficient is just going to be the number attached. Okay, so it really all hinges upon what is your degree of the polynomial. Everything kind of trickles down from that. Okay. In this one, you notice the difference between this one and the last one is we have x's and y's running around instead of just x's, right? So look at this note over here. It says if you have more than one variable, add the exponents together to get the degree of each term, and the degree of the polynomial is the biggest one of those. Okay, so we're going to look at each term, right? So here's term, 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 and term, right? We're going to add the exponents in each term. So 3 plus 2 gives us 5. 2 and 7 gives us 9. Then we just have 2 and 0. Okay. So the degree of the polynomial is whatever is the biggest number in blue. Okay. So obviously 9. And then everything else is the same as the last one. Because our degree of the polynomial is 9, so we're looking at this guy. This is the leading term, that whole thing. And then our leading coefficient is the number attached to our X's and Y's, okay? So all of that is just using pretty much those definitions, okay? We can also add and subtract these polynomials by doing something else that you're pretty used to, okay? Combining like terms, right? We've done that. I've said that in previous videos, okay? And this little note here is very important. If you're going to miss these, this is what you're going to forget to do. You have to distribute the negative if you are subtracting, okay? If you are subtracting, distribute the negative. If not, we're just going to add like terms as usual, okay? So in this example, 9x plus 8 plus negative 17x plus 5. Okay, so we are going to add like terms. So 9x minus 17x, and then 8 and 5, right? So we get, I'm going to use the same colors, negative 8x, pink, plus 13, right? So just strictly adding like terms. Okay, look at this one. Well, I'm going to make a little comparison here. In between our two sets of parentheses, we're adding. In between these two sets, we're subtracting. So this is the note that's really important. We need to distribute this negative through, which means we're just going to change the sign of everything in the second set of parentheses. So x squared is going to be negative x squared, negative 8x will be positive 8x, 9 will be negative 9. Okay, so now we're looking at this, and we need to highlight our like terms. Okay, so we have a cubed, but we don't have anything to go with the cubed, right? So that's just by itself. We have 2x squared minus x squared, negative x plus 8x, and then negative 11 minus 9. Okay, so 6x cubed didn't have a buddy, so it's just 6x cubed. Then we had the blue, so we had 2x squared minus x squared, so that's plus x squared. Minus x plus 8x, so plus 7x. And then negative 11 minus 9, so that gives us minus 20. Okay, so that would be our answer. Only difference between this one and the one before is that we had to just swap the signs, right? We had to distribute that negative, swap the signs of each one, and then we were good. Okay. This one, the only difference is we have two variables, right? But the same thing goes. In order for you to add like terms, everything has to be the same. So we have x squared y. You can only add that with an x squared y, okay? If it's not, then it's not like terms, right? Okay, so again, let's highlight. We have 5x squared y plus 2x squared y, and then negative 3xy minus xy. So we get 7x squared y. Notice that I'm not adding my exponents or anything like that. My x squared y stays my x squared y. I like to say it like this, right? Think back in kindergarten, this is how you learned how to add, right? If I have 5x squared y's and you give me 2 more x squared y's, well, now I just have 7, right? It didn't change the fact that I have x squared y's. It just changed how many I had, right? Okay, so that's how we want to think about that. And it would be minus 4xy. And we're done. Okay. This one's a long one. Okay, we have a negative here. So that means we need to distribute it. So we're going to change the sign of each one. Okay, so we have, I'm going to rewrite this line, this first line. Okay, we're going to change it to plus, and then we're going to go minus 2x to the fourth y squared plus 3x cubed y plus 4y minus 6x. Okay, now I'm going to highlight like terms. I have x to the fourth y squared here and x to the fourth y squared here. I have x cubed y and then x cubed y. And then I have just y's. And then my x doesn't have a buddy, so it's just by itself. Now add, so we have just 1x to the fourth y squared. You don't have to put that 1 if you don't want to. Plus 8 plus 1y minus 6x. Okay, just like that. And that is how we add and subtract polynomials. And we learned a little bit more about some definitions of a polynomial.